Welcome to Homework Lib.
Hi, so over here we're asked to answer some information regarding the following redox reaction that we have copper 2 plus in aqueous medium plus 2 equivalents of silver as a solid that is going to react in order to produce copper as a solid plus 2 equivalents of silver plus in aqueous medium. Okay? So first of all, the standard reduction potentials that we're going to employ are silver plus 1 electron. And it's going to, in order to produce silver as a solid, has a standard reduction potential equal to 0.8 volts. And the other one that we're dealing with is the one for copper that corresponds to copper 2 plus 2 electrons is going to produce copper as a solid with a standard redox potential of 0.34 volts. So, first of all, as you can see in a reaction, copper is being reduced and silver is being oxidized. Okay, so my E0 for the cell will be equal to E0 for the reduction, what happens at the cathode. So E0 cathode for reduction minus E0 for the oxidation that occurs in the anode. So this becomes 0.34. Recall that cathode corresponds to the reduction, so this occurs in the cathode. And in the anode, we're going to have the oxidation, so this corresponds to the anode. Okay, so with this information, this is 0.34 minus 0.8 volts. This is going to give us minus 0.46 volts. Now, how many electrons have we changed? Well, of course, we need to multiply the first equation by 2, and then we're going to add them up in order to get my original reaction. That means that n is going to be equal to 2 because 2 electrons, as you can see here, are the ones that are going to be exchanged at the very end. Now, the equations that we're going to use in order to answer what other information we have left are the following. First of all, let's remember that delta G is equal to minus RT logarithm of K. We also know that delta G is going to be equal to minus NF E0 potential. And we know that E0 for the cell, this is basically equating both of the equations, is going to be equal to RT divided by NF times logarithm of K. Okay, and over here with delta G naught. So we know that E0 is lower than 0, so that implies that delta G naught, it is going to be larger than 0. If delta G is larger than 0, this is going to be towards the reactants. And if the reaction is favored towards the reactants, that means that the value for K is lower than 1. And with that, we have all of the information that is required of us. Thank you very much. Have a good one.